Got it. Oh, I wonder if I pressed leave meeting. That would have been something I would have done. Ugh, I'm sorry. Okay. All right, guys, let's go ahead and jump in. P5, so prerequisite section number 5, talks all about polynomials. And there's some important definitions that you have to know before we can really simplify polynomials well. So the first thing, every polynomial has what are called terms. Got it. Oh, I wonder if I pressed leave meeting. That's me. That would have been something I would have done. Oh, everyone, sorry. I was talking to her. This is not. All right, guys, let's go ahead and jump in. P5, so prerequisite section number 5, talks all about polynomials. And there's some important definitions that you have to know before we can really simplify polynomials well. It's true. So the first thing, every polynomial has what are called terms. Got it. Oh, I wonder if I pressed leave meeting. You're gonna hear yourself. There it is. Sorry, guys. If I don't press mute on that, then it will. Not like hearing yourself. I hate hearing myself, but there we go. Okay. And now you need to know these terms. Every polynomial has what are called terms. A term is a constant, a variable, or the multiplication of constants and variables. So go ahead and write it down. It is a constant, variable, or the multiplication of constants and variables. Now, one thing I always appreciated about math or math textbooks is that they always had an example to go with the definition. I'm more of a visual learner, so I have to see what are you talking about with these words. So here's an example of what these words are. A constant would be like the number 6. A variable would be like the variable y.
What does it mean by like?
The multiplication of constants and variables. Oh, 6, a constant is essentially just a number without a variable. Yeah, without a variable.
Just like any
whole number, yeah. And then and it could even be a fractional number. So I can't quite say whole. It could be 1/2. It could be
like a decimal.
It could be any real number. Any real number.
Could be any real rational number. Could an example of a constant be like pi?
You could have a constant of pi. That would be an example of a term. Good question. Okay, or constants and variables. So, sorry, the multiplication of constants and variables. So if I times these together, it would be like 6y. Now, if you have one or more terms, you have what's called a polynomial. So a polynomial is the sum of one or more terms. Go ahead and write that in. Oh, one other thing with the term, I'm sorry. This is helpful as we move forward. When you start working with polynomials, it's helpful to know that terms are always separated by addition and subtraction. So I'm going to put in parentheses here. It's just helpful to know. They're always separated by pluses or minus signs.
What do you mean?
The terms. So let me give you an example, and we'll see more examples as we go on. But 6x plus y would have 2 terms. I know that 6x is a term and y is a term because it's separated by that plus sign.
Okay, so like, okay.
So their 2 pieces will make up 1 value. Now this is an example of a polynomial. This would be a specific type of polynomial. This would be a binomial. Exact, because there's 2 terms. Exactly right. So a polynomial is the sum of one or more terms. Go ahead and write it in. It is the sum of one or more terms. Some of you are more English oriented, and these prefix, right? Isn't that what it's called? The word right in the front?
Yes.
Mono, do we know what that means?
One.
One, good. So a monomial is if you have a single term.
So if it was like 6.
If it was like 6y, yep, or 6x, yep, or 6xy. Any of those. A binomial, what does bi mean?
So would that be a binomial?
The one that I gave you up here, that would be a binomial. So yeah, a binomial, we have to make it mathy. It's the sum of two terms. So binomial is the sum, which means you add them together of two terms.
But like, what if you can't add those ones there? So if it was like 6x plus x, would that still be?
No, that would
binomial,
turn
or
into,
still
that
be
would,
a monomial?
yes, that would turn into a monomial.
But
and-
just like, when you mean like, put them together, you don't.
I mean, after it's in standard form, so that's down here. When it's in standard form, that's when we identify it as a monomial, binomial, or trinomial.
Okay.
And standard form, you're gonna see all like terms have to be combined.
Okay.
Mario,
What if it's like 6x plus x?
then that would turn into 7x, and that would be a monomial. Caroline,
So 6x on its own is a.
monomial, yeah, good. Yeah.
So,
A monomial is just a term, yeah.
and then how far can it go up? Can it be like a
After trinomial, we just call it a polynomial of however many terms you have.
polynomial of 4 terms?
Yep, of 4 terms or 5 terms or 6 terms, however many
Or it
terms
can be
there
a
are.
5-term polynomial.
Be a polynomial of 5 terms, yeah. So this is the last one that we identify with its own word. And then like you heard Haley say, we just say polynomial of how many terms you have. So a trinomial is going to be the sum of how many terms do you guys think? 3, exactly right.
So like 6x plus y plus c.
That would work. Or you could even do something like this, 6x squared plus 2x plus 1. I can't combine those because they're not like terms, which we are going to talk about as well. Now, within each polynomial, we often talk about a word called degree.
Wait.
Oh, sorry.
Oh, you can put a square. Okay.
If you're talking about the degree of a term, you're talking about the exponent on the term's variable.
Sorry,
No,
for binomial.
Yeah.
Would 6x plus 2, would that be?
that would be a binomial. Yeah, you could add that as an example. Nice. So the degree of a term would be the exponent of the variable of the term. So the degree of the term is the exponent of the, I'll just say terms variable. And let's take a look at an example. Example, if I gave you 6x squared, what would be the degree of this term? 2, exactly right, because the exponent is 2 on that term's variable. Yep. Now, when you have a polynomial that has many terms, the degree is referenced as the highest exponent.
So you don't.
You don't add them if they're not like terms.
So if there was like 6, 8, 9, it'd be 9.
If it was 6x plus, wait, you mean, because you're talking about the exponent.
Yeah.
So if you had x to the 6th, x to the 8th, and x to the 9th, the degree of that would be 9.
Okay.
Good.
Yeah.
Nice, nice. Okay.
So what's the thing I missed? The exponent.
We'll write it. We'll write it as our example,
The degree
okay?
is 2, because like it's basically saying like what is the exponent like to the power to the degree, I guess.
So the degree of a polynomial is the highest.
Why'd you say 3?
Yeah, why'd you say 3?
I don't know. I'm sorry. I think somebody was, I'm so sorry. That should be 2, degree 2. Thank you. All right, the degree of a polynomial is the highest exponent in the polynomial. So I'm going to use the example actually that Haley just said. If I had something like 6x to the 9th plus x to the 8th plus x to the 7th, if I'm asking what is the degree of this polynomial, what would we say?
9.
Nice, because the highest exponent is 9. So it'd be a degree 9.
We wouldn't be able to like. Well, you could-
Add those, we couldn't. If we were multiplying, we could multiply that. But
Why
we'll
can't we
get
add
there.
them?
We'll get there. We can't add them because they're not like terms. We'll define like terms in a
Oh,
moment.
because they're different powers.
Right, right.
Can you add the two X's? No, because
You
they're like
can't-
on a different degree.
Yeah, because at like terms, we'll get there, but they have to have the same variable raised to the same power.
If they were the same power, would it be like X to the 14?
Only if you had x to the 14th plus,
X to the 14.
that would give you 2x to the 14th. We'll get there. You guys are a little bit ahead. Let's
Okay.
just talk about these terms right now and then,
We're like literally able to solve that, so.
but then we'll get there. You'll see what you're able to solve, which you guys, these are really, really good questions. Okay, here's the important piece to know. A lot of you were asking, well, how do I know which term to use? Every polynomial has to be put in standard form before you identify these pieces. Standard form means all the like terms have been combined and the terms are written in descending order by degree. Do you guys know what that means, descending order by degree?
Highest to lowest.
Highest to lowest, exactly. So here's an example of a polynomial. Notice the terms have an exponent of 3, 2, 1, and technically 0, x to the
Why is
0.
that 0?
X to the 0,
Because there's no X.
what's any number to the 0 power?
1.
Exactly, 1.
So can you like put 1?
You could, you definitely could. And we'll look at it in this example here. Well, we'll look at it down here. We'll look at it down here.
So if that were to be 5x to the 0, that would just be 5.
Yes, technically, it would come to you simplified as 5, but that term would have a degree of 0. Good. All right, I think we're ready for this chart, which gives you some examples of polynomials. This first polynomial, you can see, is a trinomial because it has 3 terms. You will be asked to list each specific term. So you can see that the 3 terms in this polynomial would be 2x squared, negative 3x, and 4. The degree, this one's done for you, is 2 because the highest exponent is 2. If I look at this next one, this would be a binomial because it has 2 terms. These would be the 2 specific terms, x to the 8th and 5 to the x. You guys tell me, what would be the degree of this binomial? 8, perfect, because the highest exponent is 8. On to the next one. This one is not in standard form because x cubed should be written first, but it is a polynomial of 4 terms. These would be the 4 terms. Here they put them in order. What would be the degree of this polynomial? 3, perfect, because the highest exponent is 3. The next one is a binomial. You can see that because it has 2 terms. The 2 terms would be 5x and 1. What would be the degree of this binomial? 1. Awesome. There's always an invisible 1 if no exponent is shown. Haley.
So when it comes to like the constant term being like the power of 0 and it ultimately equals 5, would it just stay like that or would it be 5 to the power of, or just like
5 would
flat
have-
5?
So if you look back at the degree, see how it says the exponent of the term's variable? 5 doesn't have, or even the number 6, it doesn't have a variable, right? So we could add in a variable of x to the 0.
Okay.
Because 6 times x to the 0 is really
So
6 times 1. But it's
it
always
would
going,
not have an exponent.
it's not going to have a variable with an exponent.
Okay, so
The
just like
exponent
5
of
to 6.
6 has an exponent of 1.
Okay, that's what I was asking.
Yes.
I didn't really know how to ask.
Yes,
So
the
in the
x-
end, it will just be 6 to the power.
Yes, yes. Okay, guys, how about this next one? This is a monomial. What would be the degree of this monomial? 5, awesome. And this last question. This one's tricky. I think some people already know it based off of their questions. Yes, the exponent or the degree of this one would be 0.
That's like 6 times.
It's technically 6x to the 0. It will always come to you as 6 or 6 to the first because you don't have to show a variable if it's x to the 0.
But if it's not shown, it's just 0.
The variable's exponent is 0.
Okay, but if it doesn't have a variable, it's just.
The exponent of 7 would be 1. If I asked what's the degree of 7, it would be 0.
Okay,
So the exponent of 7 is 1, but the degree of 7 is 0. Katie? Yep. Caleb?
So can you go up beyond a trinomial?
Yes. So you'll see it like this one. It's just how many terms it has
7 polynomial
of 7 terms.
You didn't let me.
Did you do that last year?
No.
Maybe. You probably did in algebra
I
1.
remember like how many.
Maybe you're thinking of like
Maybe.
different size shoes.
Algebra one.
Algebra 1, you probably
So
learned it.
Basically, the exponent of a constant is one.
Yeah, yes, but the exponent of the variable,
Exponent of a variable is
zero, right.
All
All right, guys, you have such good questions. Let's move to how do we add and subtract polynomials? You have to do this. You have to add and subtract polynomials in order to put it in standard form. So when you're adding and subtracting polynomials, you're still going to use your properties of real numbers that we've already learned, but you do have to know what like terms are. Like terms have the same variable raised to the same power. So go ahead and write that in. Like terms have the same variable. And I'm going to put in parentheses s because it can have more than one variable. You could say like 6xy. So they have to have the same variable or variables raised to the same power. Here's an example of what like terms might look like. If I have 6x squared plus 4x squared, these have the same variables raised to the same power, so they're like terms. I can combine these, and you guys already alluded to this, but this would actually turn into a monomial. What is 6x squared plus 4x squared? Exactly right, 10x squared. So, and that's a good thing to make note. You add the coefficients, but you keep the variables with their powers. If it was 6x squared times 4x squared, then it would be 24x to the fourth. Yes, only multiplication you add the exponents.
And division. No, that's subtraction.
What do you need zoomed in on? Good. Okay. Can you just wait till Katie gets back? And then yes.
Yeah.
All right, guys, let's practice doing what we just learned. So write each polynomial in standard form. Remember, standard form, I'm going to go back to that definition. That means all like terms are combined and the terms are written in descending order by degree. So highest to lowest. Okay, with that said, write each polynomial in standard form, then list its terms and state its degree. This is what the first few homework questions will look like. You'll have to fill in these boxes. So let's start with this first one, letter A. Caroline.
Would you define the?
Nice. Sophie's in you. There's a lot of talking going on back there. It's kind of distracting. You guys okay?
Yeah.
Okay, so Caroline made note that we're going to add the x cubes together because they're like terms. What's 3x cubed plus 2x cubed? Good, 5x cubed. What would come next?
X squared.
Awesome. And then the negative 4x.
So that would be negative 4x.
Yes, you keep the sign with the term when you write it down. Good. All right, what type is this? Nice, trinomial.
Will we not just like try?
Just write trinomial because it's a polynomial.
So when we're figuring out the type, you want us to solve first.
You have to solve first, yeah. Then the terms that we have would be 5x cubed, comma, x squared, comma, and negative 4x.
Oh, okay. I wrote it out like a problem.
So you want to distinguish that there's three specific terms here. And then what would be the degree of this trinomial? Nice, because the highest exponent is 3. All right, letter B. What's 4x plus negative 6x? Oh, I think plus, but yeah, you could look at it as 4x minus 6x. Good, negative 2x. So we have negative 2x plus 5. That's in standard form. What type of polynomial would this be? Nice, binomial, because there's two terms. Distinguish the terms. You would have negative 2x and 5. And what would be the degree of this binomial? Nice. All right, try the next one on your own, letter C. Put it in standard form and then answer those 3 boxes. I'm going to walk around, see how you're doing with it, and let me know if you have a question on it.
This is an order.
No.
Oh, it's not order?
No.
But there's a whole thing where like.
Yeah, it is. I think they just. I don't know. I'd ask her. No, you can't do negative two ones. Because they're not the same. Because one's a, one's a power of four ones. You can do,
Oh, like where?
Is that a question? Even if, it's negative three x to the fourth, that's still even, or just do, yeah, but like, how would that go in order? So you would do negative three x to the fourth. So you put it in order by degree, yes,
But this has to
that would, okay. So it'd be like this. Should it be negative three x and fourth plus two x squared? What?
Yeah.
Oh.
All right, guys, let's check our standard form. We should have negative 3x to the fourth. That's the highest exponents. We'll put that first. Plus x cubed. And then there were two like terms here. Negative 2x squared plus 4x squared gave us 2x squared. What type of polynomial was this, or is this? Trinomial, nice. Make sure you can distinguish the terms. We have negative 3x to the fourth, x cubed, and 2x squared. And what's the degree? 4, nice. Sophie? Yes, only after it's in standard form. All right, letter D, you're subtracting one polynomial minus another. Do you guys know what we have to do with this negative? Yep, you can make it a -1 and then distribute into all pieces. What's in front of this first set of parentheses? Yeah, you could say nothing or you could say 1. You're both correct. We can take away those parentheses because when you distribute 1, you get -a squared minus 3 back. But the next set of parentheses, because there's a negative in front, I have to be very careful in distributing. So -1 times 3a will give me -3a. A negative times a negative is a positive, so I'll have plus a squared. A negative times a negative is a positive, so I'll have plus 5. And now let's start with the highest. Negative a squared and positive a squared combine. What do they combine to equal? Yeah, they cancel because they combine to be 0. Then what would come next? Good, -3a, and then what's -3 plus 5? Positive 2. So there's my solution. What type of polynomial is this? So once I simplify it, right, it's a binomial. I want to distinguish those terms, so I'll have -3a and 2. And what would be the degree of this one? Nice. Okay, letter E. Letter E, go ahead and try this on your own. If you're stuck, look up here. I'll be doing it with you. Okay, check up at the screen when you're finished. Haley?
Why? Oh, because like terms between eights and. But, the positive one doesn't do anything to like,
It just takes away the parentheses.
okay,
So if there's nothing in front, you can just take them away.
okay.
All right, guys, how do we do? Do we get 2x squared minus 16x plus 6? It's a trinomial. It has 3 specific terms and a degree of 2. All right, you are set with your vocab that you need for polynomials. Tonight's homework will be over this content. So now we're going to transition to going over last night's homework. So if you guys could take out your P4D
So we're gonna look at this.
homework, we will finish that tomorrow. So good question.
Wait,
Yes.
so would the largest degree for D be 1 because the 2's cancel out?
The largest degree for D, yes, because they add up to 0. Yeah. Right. So usually you guys have a bell ringer with the answers on the back. Because we went over the test today, you do not have that bell ringer. So I'm gonna go ahead and show the solutions up here. I would just correct the evens and see, I'll stop and answer what questions you guys have. Does anybody still need this? Okay, so Unit 2 homework. Yeah,
I think I forgot to put this on the top of my homework when I submitted it, but I got my 0.
oh, thank you. I'll be walking around too, so it's okay.
Yeah, I messed up and I started giving all of this 60.
Why are the, oh, those are the ones that weren't shown?
Yeah, guys, the highlighted ones are the ones that were not shown to you in the given solutions. So those will probably be the ones you want to check right now. Mario?
So 61A, when we got to W6/3 and then over W1/3, why did we not simplify the 6/3?
Because you have to simplify the whole expression. And the reason we didn't simplify the 6/3 is because when I'm dividing two numbers with the same base, I have to subtract the exponents.
So I had to do that first before.
Well, you could call 6/3 2, but then if you take 2 minus 1/3, you're gonna have to change it back to a common denominator anyway. So it's easier to not simplify it and call it 6/3 so that it has the same denominator anyway.
You go to 62B.
Sure. 62B. Anybody else?
Oh, yeah.
Dominic? 64A, yeah.
What's the, what's the exponent for C?
In B, 68B, 2.
No, the exponent.
In 64B, 9/8.
Oh,
9/8. 62A is x to the 5/4. 62A?
Oh, wait, no. Okay.
No, never mind.
I was messing.
Okay, so the current,
Can you go over 68A as well?
Yeah.
And then. And
you could have it like this. Y to the 3/4 z squared over -2.
you like supposed to square root the.
No, 62, I'd probably leave it like this. 4 over y to the 1/3.
I did, because I'm doing it.
Yeah.
I don't know if I was like doing it wrong because I like saw a pattern and I just started doing it. I got like 16 and then I would do that and then I would get that.
So 16, you do want to do the 4th root of 16, but that should come out to equal 2. Because
Oh,
16,
right. Okay. And then how would that look then? Like,
Just
is that
two.
just wrong?
yeah, you wouldn't have an exponent on 2. Because the 4th root of 16 is
So it'd
2.
just be 2 y to 4th 12.
Which one is this? 60.
68.
Yeah. But y, I think you started combining the x's and the y's
Mm-hmm.
because x would move to the bottom. It would be x squared on the bottom.
Mm-hmm.
And then this y, you'd move to the top. And then when multiplying two numbers with the same base, you'd add the exponents. So you'd have to do 1 plus 4/12.
What do you think?
So can I borrow your pencil? This one you would bring to the bottom. This is y to the first. When you bring this to the top and make it positive,
So would it be? So it would be 2. 12, and then X to like that.
Yeah.
Okay. Oh, it just looks like I seem like I forgot to do that. And
Yeah.
did I just do the same thing for that one? I just forgot to.
I don't know.
switch it.
We're gonna do that one, so hopefully
Okay.
that'll help with that. All right, guys, let's start with 62B. I'm gonna show you what we would do on that one. Yeah.
I just looked at mine again and realized I forgot to do 68.
Okay.
Would that be like?
If you don't have questions, you can do it right now.
Yeah,
That's fine. It's 1, so that's okay. Thank you for telling me.
Yeah.
All right, guys, 62B looks like this. 62B. Oh, this one. It's a good one. It's a good one. Okay, first thing we have to do when you take two numbers and raise it to an exponent, you have to apply it into both. So this is going to become 2 squared y to the, when you raise an exponent to an exponent, you multiply. So 4/3 times 2/1 is going to create 8/3. Then I had y to the negative 2/3 on the top, but I want to bring that to the bottom so I can make it a positive exponent. So you see in my work here, I now have y to the 7/3 and y to the 2/3 in the denominator. When multiplying two numbers with the same base, what do you do with the exponents? Add them. Good. So this is going to create a y to the 9/3. 2 squared, I know what that value is. That turns into 4. And then finally, when I'm dividing two numbers with the same base, what do I do with those exponents? Subtract. So I'm going to have 8/3 minus 9/3. Yeah, so it'll turn to 4y to the negative 1/3. And then to make that final answer, we need to bring it down to the bottom to make that negative exponent positive. Right.
Anytime you get a smaller fraction, you just like place it on the top and then move it down.
What do you mean, a smaller
So, like, after
fraction?
you, like, when
When-
you subtract the two fractions, you just put the new fraction that you got from those two on the top and you just. Like,
Yep, and then you
always
can-
goes like that.
You could do that, or if you want to use what we did in the last chapter, you can always take the higher number, like 9/3 is higher, and subtract the lower number, 8/3, and it will stay in the position of where the higher number was.
Okay.
With fractions, it's sometimes hard to determine what's the higher value.
Mhm.
So you might want to go back to what we did with the rule.
Mhm.
All right, 68 B,
62B is 4y to
that 4 over y to the 1/3.
the over.
68B, we have this expression in blue. When you raise an exponent to an exponent, you multiply. So I need to bring that negative 1/3 into each piece. And that gives me negative 8 to the negative 1/3. When I multiply 3/4 times negative 1/3, it's going to simplify to be negative 1/4. When I multiply 3 times negative 1/3, it multiplies to be negative 1. And when I multiply 6 times negative 1/3, it multiplies to be negative 2.
Oh, did you just reduce it?
I multiplied.
3/12?
Yes.
Okay.
Yep. Then I see all of these have negative exponents. So I need to make all of them positive. So I'm going to basically flip this fraction. The y to the negative first is going to go to the top of y to the first. Z to the negative second is going to go to the top of z squared. Negative 8 to the negative 1/3 is going to go to the bottom, making it a positive 1/3. And y to the negative 1/4 will go to the bottom, making it y to the positive 4. Now, negative 8 to the 1/3, I can simplify. That's the cubed root of negative 8, which does turn out to be negative 2. Caroline?
If you're moving to the bottom, when you.
Not the 8, just the exponent. Just the exponent. Because the base, the rule that we know doesn't pertain to the base. A to the negative m just goes 1 over a to the m. So if the-
Negative.
so if
You're
the-
allowed to have that?
You're allowed to have a negative
Okay.
number. Yeah. Then the y to the first over y to the 1/4. I know when dividing two numbers with the same base, I have to subtract the exponents. So 4/4 minus 1/4 gives me 3/4. That's positive, so it's going to stay in the top. And then last thing I have is that -2.
It applies to the exponent, right?
What'd you say, Sophie? Yeah. And you can keep it like that, or you could call it -1/2 times y to the 3/4 z squared like the book did, but both of those answers are fine.
Where did you get y?
I did y to the first here minus y to the 1/4. And when you divide two numbers with the same base, you subtract the exponent. So 1 minus a common denominator. Yep, 4/4 minus 1/4 gives you 3/4.
Two with a -2. Make it fun.
The -2 you don't make positive because it's just -2. Only negative exponents you need to make positive. Zinnia, just go to the answer.
Yeah.
It's 2y to the 4/3 over x squared. And I think actually somebody asked on 68A, so I'll go ahead and show that one as well. Where is it? Somewhere. There's 68B, there's 64B, there's 62B, there's 68A. Okay. So 68A originally looked like this. We have to bring in the -1/4 by multiplying, because when you raise an exponent to an exponent, you multiply. So 8 times -1/4 will give you -2. -4 times -1/4 will give you a +1. 16 to the -1/4, you could think of that as 16 to the first. 1 times -1/4 gives you -1/4. 4/3 times -1/4 will give you -4/12, which is actually -1/3. Then I have to make all the negative exponents positive. So I'm going to bring x to the -2 down here. I'm going to bring y to the -1/3 up here. 16 to the -1/4, I need to bring that up here. And then I can simplify. 16 to the 1/4 is the same as the 4th root of 16, which is 2. When multiplying two numbers with the same base, you add the exponent, so that'll become y to the 1 plus 1/3. And then I need a common denominator here, so I'll multiply this by 3/3. And that gives me 2y to the 4/3 all over x squared.
And you got, how'd you get, because the 2 was in the negative.
It was 16 to the -1/4. And then we had to bring it up to make it a +1/4. And then 16 to the 1/4 is equivalent to the 4th root of 16.
Okay, so did you get the x to the squared because
Because when you multiply 8 times -1/4, you get -2. You get -8/4, which turns into -2. And then you bring that to the bottom. Yep. Woo, good stuff, guys. All right, I'm going to be walking around to see, to record your homework. Quick reminder, I know it's been on this board behind Caroline for like a couple weeks now, but you do need to show work for problems in order to get full credit. If no work is shown, it's a 2 out of 10. If it's not graded with the given solutions from the night before, it's an 8 out of 10. The way to get a 10 out of 10 is to try every question with work. So just as a reminder, I know that that's been up there, but that's what I'll be looking for when I walk around. Next thing, we are going to move into the group work, and I would like to start this with you to hopefully help you start well. So if you guys could go to your on campus, and actually I'll just keep that up there. On campus, you want to look under assignments. This is one of the assignments for tonight. Everybody who was in my previous classes, they finished it in class, so I'm hoping the same for you. So then the only homework would be P5 for tonight. But let me show you what the assignment should look like for this group work.
we have it on paper.
I do have a paper copy, but you'll have to submit it online then. It looks like this, rational exponents maze. So you'll send this to your OneNote. It's called P4 maze work. That's the group work that we're doing today. It looks complicated. It's not as bad as it looks. We'll start it together and you can see really how it flows nicely. If you want a paper copy, I do have one, but you will have to submit this. I'm not checking it in class. So just so you know if you want the, so. You'd have to take a picture of it with your work.
Yeah.
Ugh, paper crown. Oh. All right, guys, let me show you how this works. So the directions are rewrite each,
Sorry, we check our.
I'm going to in just a moment. Rewrite each expression in simplest radical form. Use your solutions to navigate through the maze. So you're going to start with this first piece. In fact, you might want to write these rules off to the side because they're important to remember. If you have a fractional exponent, there's two ways you can simplify it. If you're simplifying a radical, it's easiest when you put the m underneath and then simplify. If you're working with a number, sometimes it's easier to work with this format, the nth root of a, and then raise it to the m power. Those are rules that we learned really at the beginning of this week, but they show up all over here. So let's see how we would work with this. You'd start in the start box. This try to do without a calculator. All these questions would be done without calculator on the test, so try that. If you really need the calculator, you can go to it, but I would try to do without. If we convert this to a radical, x to the 1/2, what would be the index? 2, good, so we'd have the square roots of x to the first. So I want to see which way does that match? This way, this way, this way, or this way? It would technically, I believe it goes to the right, so I would highlight the answer.
Cause like.
Oh, yeah, that's right.
And then that points me to the next box, 27x to the 1/3. Now, notice the 27 is in parentheses. So you have two options. You could apply the 1/3 to both of them and then convert to radical, or you could put the cubed root under, or put the 27x underneath. What you have to recognize is the 1/3 is being applied to both. So you could have 27 to the 1/3, x to the 1/3, or you could have this. But then we do have to simplify. What is the cubed root of 27? 3, good, because if I factored it, it would be 3 times 3 times 3. So I can take that out, and that would be 3 times the cubed root of x. So then I would have to see which way does that match, up, to the right, or down? Up, so I'm going to go up. I'll do 2 more with you, and then I'll have you work with your partner. So now we're at the next one. Try this one on your own. I want to see if I can catch any mistakes here. Okay, check up here when you have it. This one you want to be careful of. 7 has an exponent of 1. It does not have an exponent of a fraction, so 7 should not be in a radical. This could be read as 7 times x to the 2/3. So the correct answer is actually going to go diagonally up to the left. Mario.
I'm assuming points would be off if you don't add the multiplication symbol.
No, if you had the answer just like this, the way it's written, that's fine.
Oh, but what is that? Okay.
All right, 2 more I'm gonna do with you, and then I'll let you guys go. X to the 3/4, which one is the index? 4, good. So we have the 4th root of x cubed. Obviously, that one would go to the side, but notice how it does have the incorrect answer. If you said the index was 3, you would be moving this way, which is the wrong way. So just be careful. Sometimes it does have your incorrect answer shown. So we're moving to the right. Now this one, 2x raised to the 7/3 power. I just want to show you how you could do this without a calculator. So the entire thing is in parentheses. So this one, the 2 will go underneath the radical. It's cubed root of, you could say 2x to the 7th power.
So it goes to both of them.
It does go to both of them. If you would prefer, you could go this way and say it's 2 to the 7/3 times x to the 7/3.
So could you also write, under the radical to the 7th x?
Yep, in fact, I'll do that. 2 to the 7th, x to the 7th. Now, what's helpful about what Haley just said is you guys know 2 to the 7th really means, I'm going to use a smaller pen so I can show it here. It really means 2 times 2 times 2 times 2 times 2 times 2 times 2. 7 2s, right? 2 to the 7th. If it's a cubed root, how many of the same factor do we need before we can take it outside of the radical? 3. Good. So I'm going to have, here's
So,
2 times 2 times 2.
well, it's 4.
Which, oh, that's what you meant. Yeah, it will turn into 4 because the cubed root of 8 is 2. The cubed root of 8 is 2. So yes, Caleb's right. It will turn into 4,
4
but then I will have that 2 left underneath.
cubed root.
You can use the shortcut on the x, or you could draw out 7 x's. It's up to you. If you make your pen really small, you can. Look at that. I can do the little tiny guys.
Absolutely 4x. Second.
Cubed root of 2x. So it's going to go, well, there's a 2 there still. So you might want to
Yes, yeah,
highlight.
sorry.
Yeah, yeah. Okay.
To the right.
Yes. I will let you guys finish this with your partner. This is helpful for if you're working on it to check, hey, are you moving this way? Are you moving that way? To see kind of, can we get to the end? All right. You have 26 minutes to work on this. I'm going to come around and check homework and you guys can keep working.
So I have a
Am
question.
I allowed, Mrs. Prentice,
Sorry, Haley, one second. Olivia's talking to me and then I'll talk.
am I
Yeah,
allowed to work on this alone?
I'm going to be showing the answer at the end. So I mean, you're definitely allowed to work on this alone. Just I wouldn't get off the Zoom call because I'll be
Okay.
showing the solution so you can make sure you're on the right track.